Hello, everybody. Welcome to another session on the J Champions Conference, this time with Henri Tremblay de Montreal. He will talk about Java 25, which is obviously the best Java version we ever had. Henri is obviously a Java champion. He's working as a managing director and head of TS Imagine Canada. And he's also lead of EasyMock and other open source projects. And he leads the Montreal Java User Group and also DevOps for Kids, Quebec. So, Henri, the stage is yours. Go ahead with your talk, please.
Thank you, Simon. It's a pleasure to be here. And so yeah, we'll talk about Java 25. So those who follow, Java 25 is the latest and greatest LTS version. So the one everybody should try to use, actually. It has a lot of cool features, a lot of performance benefits. And I'll actually try to describe them all. Slightly afraid it will fit in an hour, but we'll see how that goes. So I'll talk about everything after 21, if you got that right, the latest LTS. And let's see. And of course, the title is about virtual threads. So it's a pun intended on virtual threads, because between 21 and 25, virtual threads got better, let's say. Okay. Then that was pretty much all mentioned, I think. And so I did different things. I'll give it back at the end, but I give a longer course, a longer version of that course with tons of feature between Java 8 and 25 on O'Reilly every 2 months, pretty much. There's none planned right now, but because I did one like last week. But if you want to follow it, it's a 4 hours of cool Java features. When the next one will be planned, probably April. So I'm working for TS Imagine. We do amazingly cool trading system. So it's a SaaS for trading for fund managers. We hire once in a while, so you can look at openings all around the world, especially Montreal. And if you're interested into trading systems, just give me a shout. Then Java 21 was a pretty big version, actually, but with a lot of previews. You can see, so all the one in bolds were floating, and we were floating there. We're not sure how finished it would be. And there's also the virtual threads that were actually ready, but they had a little problem called pinning. The pinning concept is, normally, if you have a virtual thread that cannot do anything, which means cannot use any CPU, it should be opt out, and some other task will come in and get processed by the CPU. However, there's some holes in there. One big one was unsynchronized. So if you would use, instead of using a lock or something like that, if you use it like a straight synchronize, the virtual thread would not be opt out. It would be or pulled out of the CPU. It will be pinned to that CPU and get stuck there until the locks is removed. So that was a big problem. Another one is for when you do native calls. So if you do some native calls to C code underneath, you also get some pinning because, of course, when you're in the native call, there's no really any way to see if there's a mutex going on there. And also, it's possible from the native call to go back to Java, lock something, and that's not something we're able to detect to pull the CPU out. It's a bit strange, which means that that pinning is probably unsolvable, but it's pretty niche. So we hope it won't matter in the long run. Okay. So let's see what happens to all these previews. The first one is a funny one, string template. If you see, the idea is here. I'm wondering if I can draw on this thing. I cannot draw here, right? I don't think so. Okay. I can draw my slide, I think. Yeah, I'll draw my slide. Or I think I can draw my slides. Pointer options. Highlighter, pen color. I should have done that before. I know, but I forgot. And woohoo! I want a pen. Okay, here we go. So the way it goes is you do a string, but here it's a text block, but it's the same thing. And then you could put the name of a variable here, and it will kind of infer it. This one is funny because it got removed, actually. In Java 22, they did something. People were not big lovers of especially that part here and that clunky syntax as well, the backslash. And they also figured out that there was two pieces for that kind of type inference and string template, and they could do better, pretty much. So the JDK developers decided that they could do better than that, and they decided to revisit later on. It hasn't come back yet. It should one day. They had other priorities, but this one disappeared. Interesting. It's the first one ever to disappear, which means that when you use a preview, be aware they will be modified and they might even disappear. So don't rely too much on previews. It's fun to try them out, but they're obviously dangerous. Then the foreign function and memory API. This one became official in Java 22. This is about connecting to different kinds of memory and also to do better JNI. So it's called something else, JNI, I think. So it's really for if you want to do play with out of the heap memory and called external functions. I won't demo that because it's pretty specific, but it's alive, it's there, and it's way faster than what we had before. Unnamed patterns and variable. This one is pretty cool, so I'll do a demo. And again, Java 22. A lot of things actually failed to get in Java 21. They were there in 22. So let's see about this one. I'll do a lot of live coding here because it's much funnier. And unnamed pattern is a little thing. It explains why in Java 9, the underscore became a keyword, which is rare because we do not add keywords in Java anymore. So this one became a real keyword, and the idea is to be like this. So whatever is unused can be replaced by an underscore. So of course, these two could be underscores. And anything else unused. So if you have an exception here, underscore. If you have a parameter, so this one you can underscore. I think I could even underscore this one. Yes. And what does that mean? It means that I can't use it anymore. Underscore means it's unused. And so it could be enforced by the compiler as being unused. So you don't need to call it unused or use magic tricks that the IDE supports. It's to specify something that is unused. It's not like revolutionary, but it is pretty cool to be able to specify stuff unused, especially when you have pattern matching, because the more we have pattern matching with destructure of records, for example, when we destructure records, the more we'll see fields that are unused that you would actually like to officially specify as unused. So yes, here we are. Next, here, let's continue. Another one is the virtual thread we talked about. That was in a preview, as I said. However, pinning of synchronize was a big problem, and it got solved in Java 24. right there. Of course, not of course, but the native call method, as I was saying, is a bit hard to fix. I don't think it will happen ever. So it's still there. But synchronize was pretty important. Now virtual threads are quite reliable. I hope. Next. See a lot of actions in the comments. I have no time to read them, but I know that Simon will summarize and ask questions if needed. I'll read them after because you seem to ask a lot of fun stuff. Okay, where was I? 445 unnamed classes and instance main method. This one is fun because it took some time, and as you can see, sometimes they get renamed through times. So was started to be unnamed classes, but then it got implicitly declared classes, but then we went to simple source files, and we ended up with compact source files and instance main methods. A bit more descriptive than what it ended up to be, actually. That's one of my favorite ones. So let's see about this one. 40, which is this here. Where is my 40? No, yeah, here. All right. The concept here is that we would like to remove as much boilerplate as possible for somebody starting Java. That's something, the big complaints we have from university teachers, but also from people in general. Oh my God, when Java you have too much things to do, like you have a Maven to start, you have you need to have like full configuration and IDE and everything to be able to do 3 seconds. It's a bit fun because for anybody who did any C or C++ in his life, compiling and linking is absolutely arcane. And when Java arrived, it was magical. But now, I don't know, other languages got simpler, which means people want something simpler from Java. What did we do? We simplified what was required to start an application. First thing is, if you do not need the parameters, you can remove them. Second thing is, like, you don't want to explain what's the static concept, and you don't want to explain what's a public concept at first. It's not really necessary. So this could be removed, which is the the instance main method. That's what it is. It means that a main can be an instance method instead of being a static one. And the compiler will just figure it out and say, okay, there's the compiler, the runtime will see, oh, there's a main there. Yeah, well, I'll just use that. But then they said, even the concept of a class, we would like to avoid talking about it at first. So let's just remove that thing as well. What happens there is that there is a class, but it will be magically created by the name of the file at runtime. So it just works. When you enter that state, you actually get some imports by magic. So here I don't need any, but here I could replace by something called IO, which is a new static, a new class with some static functions to do printouts. And that is really useful because the system.out was clunky, is weird. It's a bit like, why am I using that? But IO println, it's fine. It's like, it's not a straight println, but it's actually short enough to be happy. And that normally would require an import, but everything in the Java-based module is there by default when you are in that magical realm of a single file class. And so you don't need any import. It just works. Which means that, of course, if I do this, which is another thing, I can, but that has been for a long time. Like since Java 9, I can do that. I can just give the name of class and a file, a Java file, to the Java runtime, and it will actually compile it ad hoc and run it, and it just works, and it makes you happy because now we can do tons of scripting. So why would anybody wants to do Ruby or Python? I have no clue. Cool. Now, Another one, scope values. Scope values, they got in Java 25 like just on spot. They went through 4 versions before getting ready. This is a replacement to the clunky thread local. The idea here, and give me my, I don't know why my sorting is that bad right now. It's terrible. I've noticed that like for about a week, it just sorts the internal libraries before my own code. Okay. So it's really a replacement for thread local. Normally, let's say an example here is you you have an executor and you would like to retrieve some stuff in parallel through many many URLs in parallel, but you need some credential to do that. So you need an authentication header. The normal way to do that is you put that in thread local. However, as soon as you start doing it in parallel, it doesn't work anymore, because in the other thread, your thread local is not there. Which means that you need to do some ugly stuff to do it. And let me see. Here we go. By the way, I don't know if you noticed, so I'm using a virtual thread executor, and the executor services are now auto-closable. They become that like between maybe about 23, something like this. I forgot. Well, maybe before 21. But let's say that since 17, a lot of things are becoming closable. So have a look at them. Executor services have a tendency to be hard to close. Now they're really easy because they're auto-closable. Of course, somebody needed to decide what it should actually be to close it. But they kind of said, okay, it's better to decide a way of closing it than having people badly closing them forever after. And this is an example, like if it's not already terminated, we aren't doing anything. If it is, we're shutting down, and then we're waiting termination for 1 full day. And if it fails or it's interrupted, we shut down. So it's kind of makes sense, and that's what you would do. But of course, all these 20 lines of code, you won't really do it. So most of the time, unless you really disagree with the 1 day here, you'll actually close it like this. That said, I'll go here. So what you would do with the thread local version in general is I'm in the current thread that has credentials. So I'm getting my credentials, and then I'm in the other thread that will execute the thing. So I'm giving it the credential, and of course I need to finally to really remove it to prevent some security issues. Works, not great. And scope values are there for that. So our scope values are more like this. You create a scope value. It looks a little bit like a thread local. And then you just pass the scope to the thing that will need it. You can do it like this. But you could even do it that way. That's with structured task scope that we'll see about a bit before, a bit after. With structured task scope, it will be magically propagated through. The sad part is that scope values are ready. Structured task scope is not in 25. So we can't do that yet. But still, it's a really lightweight, easier to use, no trick, thread local kind of thing. Have a look. It's less memory consuming. And also it doesn't stay there stuck in the thread local forever after. It could be recycled correctly. Thread locals have a tendency to be memory leaks. Next. This is the Vector API. The Vector API is still incubating. Incubating is like a preview, but for a module. And it will be there forever after, pretty much. It looks like that, so you won't use it, most likely. It's to do matrix thingy. A bit like you would do with CUDA on GPUs. However, it was made with Intel to run on the Intel Vector coprocessor, and that's why it's still incubating, because it works perfectly. It's just that until it's widely implemented in some way, it needs to stay incubating. You need a really specific CPU to get it to work at full speed. Otherwise, it's just using the emulation. Okay, so don't expect this one to stop being incubating ever. Structure concurrency, sadly, missed the post as well. So Java 25, it's still a preview, the fifth preview. Hopefully, it will be there one day. Concept of structure concurrency is to get a feel of sequential programming as much as we can, but doing parallel programming. So it's more readable than a completable future, for instance, and more readable than any executor service you would use. It's not as nice as parallel stream, but the purpose is not exactly the same. Which means we'll wait until the next Java version, 10.29 should be, to get it. But then, of course, between 21 and 25, new features appeared. These were all the previews, so you saw that most of them actually landed, apart from structured task scope. Structured task. Let's see. So these are the things that are new, but now a preview in 25, which means I won't demo them. I'll just show a little bit of the idea, what's coming, so you can know the future. One is primitive types in pattern instance of and switch. The concept is to be able to switch on primitive types like these here, and to be able to put condition when it's I, but also to do strange things like this here. So to check if it's actually fitting a type, like this one with returning false. It's a float, so it's not an int. However, this one will be considered a float because it does fit in a float, and this one is false because it's too big for a byte, for instance. I don't think this one will land soon. It's third preview already, and we're searching what we exactly need, because this is fun, but do we do that often? Does it worth the complexity in the language? Yeah, probably not. This is cute, but mainly because we do more and more switch for many things, because switch are great for readability instead of if else. Which means that this part can make sense. This, I'm less convinced, and we'll see in the long run. We have cryptographic thingy, won't discuss, doesn't matter. Stable value, yes, they're here. Sorry, I was looking where my example was. Stable value, this is really cool, actually. This is something I really like. It's this here. The idea is, when you have a thing like a singleton, something that would be lazy initialized, but as soon as it's initialized, it won't ever change, ever. So we would like to be able to like snap a final on it as soon as it's initialized, so the JVM knows it could consider that thing final. And it wasn't possible before. Stable values are for that. Here is one flavor of it. So you create an instance, a supplier instance of a stable value, and then you will get it later on. As soon as you get it, it becomes a final thing, and it will behave like a final result. So the instance.get will be at the same, will have the same speed and the same performance benefits as a normal final value, and that is really cool. Sadly, it's still a preview, but I think this one should stabilize quickly. This we talked about it before, and this one we talked about it before. Okay, then let's see. Everything is new. The way I've presented it is shamelessly stolen from a page I'll show at the end on the JDK website. They did a good job at sorting it. And this is really all the features between 22 and 25, but compressed in like one thing. I'll discuss about everything and I'll demo whenever it's useful. One thing is we discovered that everything 32 bits is dying and there's no need to support it anymore, which is great for JDK supporter developers because they can remove all this from it and and simplify their life. So no 32 bits ever again. This one is, oh, by the way, this is the name of the version when it occurred. So in Java 24, this one happened. Deprecate memory access methods in Sunmiss unsafe. The idea here is that unsafe was used for a lot of weird things. Now we have foreign memory, we have new memory buffers, we have different official API to manage memory nicely. We should not use the things in unsafe anymore, so they get removed. So unsafe will shrink slowly because they have a nice replacement. And that's one of the things for libraries. Here, same thing, 32 bits removals. Because there's deprecation, then official removal, blah, blah, blah. More interesting. Changes to hotspot. I'll get back to flight recorder. There's a lot of work on garbage collector. Shenandoah becomes really hot, and ZGC is becoming really hot. They both now have a generational mode. The ZGC one was so cool that they actually even removed the non-generational one. It was worthless to keep it. And so this one, I think it's the future. It becomes really trendy. G1 is still the default, and they're adding improvement almost all the time. Late barrier expansion for G1 and region pinning is are too specific to be. Let's just say it's improving your JVM. And then the other hot thing is everything about AOT. So the ahead of time, which I'll discuss after. This we talked about before. And this one here, that is really, 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 really cool. The idea is that in a JVM, you have a class representation in memory, and it takes place, so it takes memory. But they found a way to actually compact this, to use a lot less bits to represent exactly the same thing. And it's huge. I think it's like a 25%, could be a 25% memory saver, depending on the size of your objects in general. But 25% of heap, it's a lot. Like it's for for Java that has been there for 25 years, finding a way to remove 25% of the heap is amazingly incredible. So just this could actually be a reason to move to 25. It's incredibly, incredibly useful. And given the price of the RAM right now, it's a lot of money. That said, let's look at Flight Recorder. So Java Flight Recorder is a profiler. It can be used in production as a low overhead profiler, and it's getting improved a lot these days. I'll show you what it looks like. These three are specific. So this one, the cooperative sampling, is about being able to do sample and while the application is running, instead of just blocking everything on a safe point and taking the snapshot and then continuing. So it's a trick to make it more efficient. This one is sadly can't be demoed, and that's why it's experimental as well. CPU profiling is to do CPU profiling like async profiler would do, but it only works on Linux, which is why I can't do it. But if you're on Linux, it will give you like really accurate CPU profiling compared to the classical sampling. And this I'll show you a little bit. So let's see if I can change my window. Yes, we're at 45. Okay, and I'll look at the time. It's not bad. It's not bad at all. Okay, so here I just have a stupid thing that gets and contain and get. So it's not really doing anything useful. It's just for the example. And so flight recorder, of course, you can start it when you start the JVM. There's even a plugin you could use. It's not installed here, but you could add a plugin in IntelliJ. And then you run your application with it. However, I'm not doing that. I'll just start it here. And okay, so it started. And the concept is I'm just getting my PID, and then I can ask for stuff. So your GCMD is the magical thing to launch everything on the JVM. It replaces pretty much everything else you had before, JMap, Gen, JHAT, J whatever. And you can ask for something like JFR start. Ooh, sorry. You give a name to your profiling. Here you're telling which profile you want. By default, there's the one called profile and one called default. The profile is more a profiler, and the default is lighter a little bit. And you find that in libjfr in your JDK. But of course, you can create your own if you want. You just modify the file. The way I did the modification, I'm tweaking here. So for example, here, by default, it's 10 milliseconds for sampling. I want 1 because 10 is it's not fast enough, I feel. And I did the same for native methods. So like if I do this, it will actually start profiling. I can check. Yeah, it's running, obviously. Then I could dump it. Oop. Like this. And I can summarize, but of course so this will tell you all the events and all the CPU used, how many samples I have, and different useful things. What was the CPU load, for example? I can stop as well. I haven't stopped, so I'll stop because I can stop my profiler. I don't need it anymore. Summary is nice, but you better use something like mission control, or here I'll actually just use IntelliJ. So IntelliJ, if I open my JFR here. Hi, do open my JFR, please. What's going on? So that's the profile file, if you're wondering. Somebody was talking about the gods of it's there. Damn it. Okay, finally it's there. I'm just blind, sorry. And here I get my flame graph of profiling, so I can see that, for example, it's equals, that would be my bottleneck of the moment. Or I can go in the call tree and see that contains is really costly, and going in equals is the best thing, which can, by the way, make you realize that, oh my god, I should not do a contains of the same thing that might get, because maybe I will be twice as fast, since the equals in contains is the bottleneck here. So simple, cool, works well. The other things I can do with it are, this is the memory trace we saw. So the if you remember this one here, the memory timing and tracing. So this addition is you can do stuff like, hey, I would like to trace all the calls to integer to string to see where they're coming from, and it will give you stack traces of it. I can demo it, but I need to be fast because they happen pretty quickly. Let me do it here. Alt do 12. Up. So PID, and then if I start, then dump, then quickly stop. Okay. And you see that even the dump is it's a bit slow because it's not that small. And there's even a command line for that, so I could open it, but come on, stop. You can do it. You can do it. You can do it. Yes. Okay, let's stop the recording. And oops, what did I do? And there's a command line for JFR, so I can actually view also my my result, and it will eventually give me all the trace there is. You can also do some timing, so you can see, hey, can you calculate the time it took for all the static initializer, for example, here. So that's the timing part. So you can ask for times of things, and you can ask for tracing of some method. It kind of replaces old stuff like I think something called Byteman and agents you would do for live instrumentation. You can do it just with JFR right away, which is pretty fun. Okay, and you see all the I'll stop it because there's way too many of them. But yeah, here they are, and you can see that they're invoked by the integer to string and from a direct method here. Okay. Next, JFR, ahead of time. So ahead of time is something really hot right now. The idea is we want to make Java fast starter, really useful for Lambda programming and ad hoc JVM, but also like if you want to do a command line tool, you would like it to start really fast. And there are different solutions. You can natively compile, but then you lose the JIT. That's sad. Another trick is if you have run that same application before, the optimization the JIT will do would probably be pretty much the same if you restart it. So we would like to remember what happened last time. And that's what this is doing. Azul is doing something similar. J9 is doing something similar. But now it's getting in the normal JDK. There was some improvement. So at first you would need to record something and then create the profile, the optimization profile. You don't need to do that anymore. So in 25, you can do both at the same time. Concept is you run your application. Why is it going crazy like that? Okay. I'll launch another one if needed. So you pass parameters saying, hey, I would like to cache all the optimization, please. And here it goes. So it just nothing fancy happened. It ran the application and it actually saved the profiling here. So what does it do? You can see it. Let's rerun the same application, which is not doing much, of course. It's just like printing stuff. This is Pearson because I'm It should be JChampion conf, like this. Pearson is because of my O'Reilly things. So hello JChampion conf, and it took like 0.5 seconds to run, which is not great because it doesn't do much. And of course, if I use it with my profiling, here we go. We're at 0.2. So I'm like almost 3 times faster just by that. And just by doing not much. I just ran the application once. It doesn't need to be the same because the JVM will take the optimizations and use them. But if it feels it's not really useful because the application changed a little bit, it will just disoptimize, reoptimize, change stuff. It's really a baseline of optimization for the C1 and C2 compiler. It also preloads some classes. There's a lot of things involved there that makes it really fast. And it is really, really, really fast. The things that are not fully dried yet is that this AOT thing should be stored somewhere for others to use. It matches the CPU where you're running the platform. So you would normally have to get exactly the same platform to compile it, and it needs to be deployed in your Maven repository, I guess. So all these are not fully there. It's like I'm missing the CI/CD around that, but otherwise it's perfectly working. It's awesome. Okay, and they're working hard on it, so we'll see that more and more after. Done. Languages. Languages will be demoed, of course, because their language. This one we saw it in the previews. This one we also saw it in the previews. So let's look at the two others. Flexible constructor and bodies and module and port declaration. These landed in 25. So we're just lucky to get them now. Flexible constructor bodies, it's something really nice that people have been wanting for a long time. I'm really happy it's there. It's the concept of being able to put something before this and super. First example will be here. Here I'm validating my Z, but if Z is wrong, why would I call super? What I actually want is to put it above here. And it wasn't possible before 25. Now, as you can see, it perfectly compiles. Problem solved. Magic. So awesome. The other example is something like this here. Here, no, sorry, this. Here, I want to extract with some pattern matching. However, to be able to do that, I'm extracting a method that I'm calling from this, and then I'm doing it twice, but then I'm kind of stuck in redoing my matcher twice. And that method is there a bit artificially because I can't do it up front here above this. And of course, now I can. And I won't refactor, I'll just show you. So this would actually now work. I'm creating my matcher. I'm looking for matching, and then I'm still extracting a method because this is still a cut and paste. So I still want to return my group, but I can do it that way, and I can pass my parameter. So it's a simple feature, but it solves a lot of stupid headaches we had before at reusing this and super constructors, because now you can put code on top of it. There are some limitations. I would recommend to read the JEP because it's not all open bar. Like, you could not set an attributes of a base class, like some pretty obvious things when you think about it that are forbidden because they would make no sense. But in general, you will use it in something that makes sense and you won't even notice. So just great feature. I love it. Cool. I see a lot of chatting. I love it. I don't see a lot of questions. I'll guess I'm fine, and we'll see if I miss some. Simon will help me out. Model import declarations. This is not a feature I'm convinced about so far. And I said, yeah. It's more if you put yourself in the module mode. If you're a module, if you develop a module, you export stuff that are now allowed to be used by the external world, and other things you keep private. So we could say that as you would do for, I don't know, a DLL or SO or something like that, as soon as you want to use a module, why would you need to import specifically every package? You could just import the full module at once, like you do with the star import on the package. An example here I'm using the HTTP server. Funnily, someone said that com.sum is bad, but actually for HTTP server, it is the package you should use. I love it for historical reasons. And here, like you could say, okay, instead of using my HTTP server, I will actually just import the full module. And if you want to check the module, JDK HTTP server here. So now that I know it's there, I can get rid of these two. Yeah. What? Okay. My keyboard was weird. And so you could comment that out and you have all your imports right away. It makes it quicker. I do agree. It's kind of nice. Being having a lot of my architect hat, I'm against star imports. And I'm against module imports as a follow-up, because I like to see, it's really easy if you do not use them to see what is using what in your code without even having to do like funky analysis of the bytecode. You can just like look at the imports, you grab the imports and you see what's using what. I love that. So I love to be really explicit on my dependencies, and a module is blurring that like a star import will do. But so I could be convinced, like if I'm hacking a script and I don't want to add tons of import right away, why not? But does it worth it? I think we were happy with or imports sincerely. But it's there. If you like it, use it. And of course, for your own code, it needs to be in the module system. So you need to have modules. The JDK is always modules, so you can do it. But for your code, you need to have modules if you want to have this import. Okay. Still on time, I hope. Libraries, a lot of improvement of libraries. Integrity by default is a new hot concept. The idea is if you have an application, you should be aware of what sneaky things all the libraries are doing. If they're registering an agent, you should be aware. If they're doing native calls, you should be aware. If they are doing weird reflection, you should be aware. And if they are using unsafe, let's say, you should be aware. Because you never know if one of the libraries you're using is actually evil and tries to do something it should not do. It makes sense from a security standpoint. And a lot of people doing Node got burned with that because they use random library from random dangerous spies. In Java, I am not aware of a lot of issues on that front. And it's really painful to manage because like you trust the libraries to do the correct things and you don't really even want to be aware, and there's no way to know it will blow up until you actually try it. So you run it in test and you hope that you go into all the paths that will destroy your JVM to be able to add your command lines parameters needing to say, yes, I'm aware. Yes, I'm aware. Yes, that's fine. But that's where we're going. It makes it really hard to like a library maintainer will now need to always specify here are the JVM args you should put to be able to use me, for example. It's a bit strange. Anyway, that's it. One is, for example, if you use JNI, it will start complaining unless you approve it. And this is if same if you're using the memory access methods from unsafe, you get a warning until it gets not a warning. It becomes not a warning, but for now it's a warning. Different cryptography, especially things that are supposed to be resistant to quantum computing, because quantum computers are more and more real, and we would like to protect against it. Oh yeah, no, this isn't important actually. The security manager. And I'll try to still have time for questions, but so I need to stop talking too much. Security manager is the thing that protects the JVM from people wanting to doing things they should not do. Like, can I call a system exit? Can I open files? Can I do whatever things? And if not, I will get an exception. However, nobody really ever used it. Google tried. Tomcat tried, nobody liked it. It's too complicated, and they actually never used. So we found better ways to prevent these things, which includes the security integrity by default thingies and other features. And this is actually a lot of code and a lot of overheads to the JVM. They're all over the place, the security manager checks. So now it's disabled. It's still there, but it does nothing. And later on, I don't know in which version, they will just delete it all, and it will be happier ever after. That is a great modification because it simplifies the code heavily, JDK side. And so this we talked about it, and this we talked about it. So let's demo the two others. Class file API is something pretty cool. For those who know ASM, it's a library used to generate bytecode. So you would call it to create at runtime classes that you would then give to your class loader that will load it. The fun part there is that the JVM does that a lot. Let's say you're creating a Lambda. It needs to create the implementation of the Lambda. And to do that, it will use ASM. So it will use ASM to do it. But it's a bit problematic because if you're Java 25, then Java 25 goes out. Then ASM says, oh, Java 25 is out. Now I will support Java 25. But it means that the ASM bundle in the Java 25 version is actually supporting Java 24, which means that the JVM has always been one step behind in terms of code generation. A bit silly. Also, ASM is not that fun to use. It's some clunky old visitor pattern, but it's been used for like years and years, and the person who did that is an amazing human being. However, now we have something built in the JVM, which allows the Java language, actually, the JDK, which allows to generate bytecode of the current version. And it's more in that field. So it's more like builders of builders. You do things like this, like, hey, I want to create a class called my class, and we'll have a method which is void private. And the code in that method is loading a value. And then and then I'm invoking, what am I invoking here? The constructor, I think. Yeah, I'm invoking the object constructor, and then I want a main method that will do a system out, and if I run that, it will generate the code and run it. Of course, I'm not executing it. I know, I'm just writing it here. Oh, I forgot. And so, which means that if I now run the class that I saved. Couldn't find our why? What did I do? I won't debug. I don't have time. But what did I do? Sorry. No other class here. Okay. And you see, I've generated my own little class, and it's like if you're in 2-byte code, it's not that hard to do compared to what it used to be, which means I'm pretty happy. Sad part is like we need to stop supporting Java, everything before Java 5, so it won't pick up for a long time before I can use that. But it's cool that it finally arrived, bottom line. Then, something funnier and closer to normal developers is called stream gatherers. I could do hours on stream gatherers. I know José Pomar did good presentations on it. And so I'll just give you the idea of it, but there's a lot more there. So it's a new thing in the Stream API. The idea here is that if you would like this thing, you decide that you want to do it all the time. So you could extract a method that will return a function that will actually do that. It's fine. But what you really would like to do is something like cat age that would just do it. Other languages have utility methods that you can plug to an existing class. Groovy does that. I think Kotlin can do that, but Java cannot, which is not a bad idea because magically appearing methods are a tiny bit annoying in terms of understanding code, I think. But that's kind of what you would like to do. And especially if it's more complicated than just a map, because here a method reference will be enough. But sometimes you want to do a reduce. So like you would do a function, but for a map multi, or like it gets a bit ugly pretty soon. And of course, string gatherers is a solution to that. I'll go here. And you would do something like this. So you would gather and call your gather cat age. And then you create your gatherer. They're not that easy. So it's really for library dudes. You won't do you won't do gatherers for fun every 3 minutes. It's something you know will be reused. It's useful, and you're a library developer. And here you create a gatherer of users, and you have a downstream all the time. The downstream is to allow you to push or not things that, so to keep or not the value, pretty much. And the return is should the stream continue or should the stream be done? And with these two things, you can do tons of combination of stuff you would like. They all start with a gatherer of, but you can do, and they have different, more complicated permutation. You have also you can be sequential or parallel as well, because some gatherers won't work in parallel. So you need to think about that. And you can see, and it's always composed of 3 pieces: the initializer, the combiner, and the finisher. Which, like, combiner and finisher are a bit map reduced kind of thing, and the initializer is for initial values. As I was saying, it is a big API. I can't describe it more in 3 minutes, but have a look, because it's pretty cool if you need to do that. And check others' presentation. That makes a lot of sense. I just want to see. Okay, that's what I was saying. I'll be late. I'll be late. Are they big? No, these are not big. This is just a better way to play with JMods. I won't describe. Nobody cares. And multi-line source program. Yeah, these are easy to demote, so it's not that bad. I'm not that late. The concept is that here, before we were able to just launch one file from the command line, but here I have a helper class which is just aside here in there. And what I would really like is to have both. Oops, no, that was fine. So we both being compiled. So it sees the first file. It will compile it. It will also see it will see that the other file is used, and then it will compile it. And then I just have a little program in the same directory, and they will all get magically compiled. And that is just awesome. Like I can extract new libraries as needed now to like extract method, because I've started to use that feature a lot, but I end up with big classes with like big files with tons of duplicated from the others, and that will actually save my problem. Makes me happy. And the markdown, what's the okay? This one 42. Markdown is something also that should make people happy. It's really the concept of here it can be marked down instead, like this. So 3 slashes, and you use the normal markdown, so you can bold, italic, whatever. And of course, you can snippet code here, and it will render correctly like markdown does. And that, like, no stupid P, no stupid HTML thingy you'll put all around. This empty line is now an actual empty line forever after. I don't see why you would not be happy about it. And I think I'm done. Not that late, actually. This you can tell in the comments. It's something I ask all the time. So who has learned something today, just to be sure it was fun, and I should replay that conference later on at some other place. All the thing talk about inside Java is a really nice place to learn about under the hood Java. So what's going on? There was a good article yesterday by Brian Gertz on where we're going with records and more. I forgot that. More components, so concept of mutable records, really cool. This is good to learn all the new features. This is the source code I used, and there's tons of other material there, so you can have a look. This is what I stole to structure all the JEPs since 21, and these are all the contents of all the JDK. So you just add the number of the JDK right aside. SDKman is awesome to be able to install Maven, Gradle, and different tools, plus flipping between JDKs. So I highly recommend to use it if you're not already. And that's it. Oh yeah, so places to reach me out. Next speaking events. So I said O'Reilly, I'll be at Kung Fu in Montreal, best conference in Canada, end of February. And if you can be there, be there. And Java 1 in March if you want to see me. And that's it. Thank you very much. Simon, is there any questions I should be aware of?
Thank you very much, Henri. No, not as far as I've seen. We had a lot of discussion between the attendees, but I don't see any questions because it was pretty clear. I learned a lot, by the way. And I certainly have to check out your GitHub repo.
Perfect. Then have a good day, everybody. Yeah. I'll be moderating Tom Cool later today at 2 p.m. EST. And Simon, thanks for your help. Always a pleasure. Hope to see you in person in about a month at Java 1.
Sure. So thank you very much for being here. Bye-bye, everyone.